Okay, so today I will discuss naman is what we call modified stiffness. Okay, so modified stiffness for moment distribution. So it's the same topic but para siyang shortcut or mas pinabilis na computation ng moment distribution. This is best for when you're doing manual calculations. Okay, so the condition is enable to use the modified stiffness. You should have, when an end support is a pin or a roller, okay, the stiffness for the interior support of that member can be modified or reduced by applying a factor of 3/4 of its original K or original stiffness. Okay, so we will apply 3/4 over multiplier for the original stiffness of the member. Okay, so this process will make the computation faster as the moments will converge faster. Ibig sabihin, mas mabilis silang lumiit kesa sa conventional or yung original way natin. Okay, so to execute the modified stiffness method, okay, the joints at the pin or roller, after applying the modified stiffness, ito yung susunod na process or ito yung magbabago sa process. The end supports are balanced only once kapag pin and roller. Okay, so when the end support is a pin and a roller, that joint kung saan yung end support na yun na pin and roller, so hindi ito applicable kapag fix yung end support mo. Okay, so it is only balanced once in the process and no moments will be carried over the end or pin support. Okay, so di pala nakabukas yung camera ko. Ayan, so no moments will be carried over the end or end support, which is condition is it must be a pin or a roller support. Okay, so balikan natin yung nauna nating example. Okay, so we have here yung nauna natin na example na na-solve na natin. Okay, so ito yung solution natin sa moment distribution. Okay, so na-solve na natin yung K, yung DF, FEM, and then up to the final moments, tapos na tayo. So in this case, can we apply the modified stiffness? Yun yung tanong natin ngayon. So, can we apply the modified stiffness? Ang sagot is yes. Pero saan ina-apply yung modified stiffness? Sa mga N support, okay? And ang condition is kailangan a pin or a roller. Okay, so tingnan natin mga end support natin. So yung end support natin dito is a pin. Ang end support natin dito is a fix. So when we say end support, yun yung mga dulo, nasa dulo na supports. Okay, so dito, since this is a pin, we can modify the K. Okay? And then dito, since fix, don't modify. No modification ng mangyari. Okay? So, sino yung modify natin na K? Nasabi dun sa ano natin, the stiffness of the interior support, okay, of that member. So, if this is the end support, so end support ito, end support, apply daw natin yung modified stiffness sa pin, sa interior support of that member. Okay, so sino ba yung interior support ng member na yon? Nag-lag. Sandali lang. Yan. Si joint na to. Okay, or yung roller na to. That is the interior support. So this is the interior support. So dito tayo mag-apply ng P4 of K. Okay, so I have prepared here na yung ating table. So ito yung original. Okay, so ito yung original. Dito gawin natin yung modified. Okay, so ano nito? Wait lang. Ayaw mag-ano. Yan, so yung original, wait lang is 0.2 sila, di ba? 0.2, 0.2. Okay, so na-spoil na tayo. So, ang mo-modify natin is yun nga, yung interior support nung may end support na, or yung member na may end support na pin or a roller. Okay, so yung member na yon is the member that is a pin, a support that is an end support that is a pin is CAB. Yung interior support is na kay BA. So yung apply natin ng modification is yung stiffness ni BA. Okay? So applyan natin ng modified stiffness ito. So imbis na 0.2 mag-multiply ka ng 3/4 dun sa 0.2 mo. Okay? So, imbis na 3/4, apply natin na imbis na 0.2, I mean, mag-apply tayo ng 3/4. So, applyan natin ng 3/4. So, 3/4 times 0.2. That is equals to 0.150. And then, the process of getting the distribution factor is same pa rin. Okay? So, let me do it from scratch. Sige. Pero lang yung FEM since na-complete na natin yan. Okay, so again, review natin. Dito ko na lang sulat yung notes ko. Tapos buruin ko na lang after. Is K over summation K. Summation K is the joint stiffness. K is the member stiffness. So, ito yung mga member stiffness natin. Acting at AB is meron tayong member AB and a pin support. And we know that a pin support has a stiffness of 0. Okay? So, that is 0.2 over 0.2 kasi yung summation K no, yung summation KA is combination of member AB and the pin support. So 0.2 plus 0 is 0.2 kaya KAB over summation KA, which is also 0.2, is equals to 1, or simply we just give a value of 1 na DF para sa pin support na nasa dulo or a roller support na nasa dulo. Okay? And then for the joint B, you have two members that are connected with joint B, BA and BC. So that is, you take the sum of this one, okay, for summation KB. So that is 0.150 plus 0.143. So ibig sabihin, the FBA is KBA dito ko na lang lagay. DFBA is equals to KBA over summation KB. Okay. So that is equals to 0.150. Okay, yung KBA. Yung summation KB is a combination of, check natin, you have a member connected sa joint B is ito. Ito yung joint B natin. Ito, member BA, member BC, and the roller which is automatic. We just give that a value of 0. So that is 0.150 plus 0.143 plus yung sa roller which is 0. Okay, so sa Excel, mabilis lang siyang gawin. So that is equals to this one. Okay. So hindi siya na-select. Wait lang. Delete ko lang muna yung mga written ko. So that is equals to this one, no, 0.15 divided by the sum of KBA plus KBC plus 0, siyempre automatic. So that is 0.152. Okay, so ito naman equals this one divided by, again, sum of summation KB, so that is this 2. Okay, and then automatic kapag fixed support, we give it a distribution factor of 0. Okay, so we will execute na yung modified stiffness. As you can see, pinay-click ko siya hanggang 3rd distribution lang. Dito hanggang 5th distribution. So, check natin if magko-converge nga siya ng mabilis. So, first distribution. So, sabi, we only need to balance it once. Okay? Balance only once, sabi dito. Yung sa end support. So, i-balance natin ito. Balance this one. Paano yung undo? Balance natin. So, that is, we apply a negative sign in front. Okay. Negative times this one. Okay, burahin ko lang yung highlight. Nadidetect na yung highlight yata. Let me erase the highlight. Equals negative times this one and times the distribution factor. Okay. So that is that one, 38.453. Dito naman sa B, so yung mga moments na mag-act sa B is this two, no? Sila yung connected sa B. So, balance the moments that is acting at joint B. So, equals negative sum of these two. Yan. Yan, dalawang yan. times the distribution factor, and we fix the location of the distribution factor sa Excel. So, dinalagyan ko ng $sign. Okay, so just press F4 para lumabas yung $sign. Okay, so para mabilis, I can drag this. Okay, ang kaso, check mo yung mga nakaselect ngayon na cells. So, dapat yung naka-summation dito is hindi itong dalawa, kundi ito pa rin yung moments that are acting at joint B. So, I will just move the selection to that and move the selection for the distribution factor ng BC. Okay, so since we're talking about MBC. And then ito, I can just copy the formula here. Or sige, i-ano ko na lang. Pakita ko na lang that is false to negative times this one times 0. And then F4. Okay. So, and then next step, sabi is you carry over. Wala ka nang i-carry over dun sa end support na pin and roller. So, no moments will be carried over at the end support. Okay? So, yun yung magbabago ngayon. So, saan ba yung end support na pin and roller natin? Nandito sa column. Nandito sa column na to. Okay? So, wala tayong i-carry over na dyan. So, yung i-carry over natin is ito, tsaka yun. Okay? So, ito, huwag mo nang i-carry over doon kasi yun nga, this is a pin or a roller. So, yun yung sa advantage ng tawag dito ng modified stiffness. Okay, so now we divide this by 2. So divide this one by 2. So we divide this by 2, and then kung ano masukuha natin sagot, yun yung ilalagay natin dito. Yun yung ilalagay natin dito. We divide this by 2, yun yung ilalagay natin dito. We divide this by 2, yun yung ilalagay natin dito. So, doing the process in Excel, let me erase yung ano ko. Nagsulat. So, that is equals to, we divide this by 2. We divide this by 2. And then we divide this by, we divide this one by 2. Okay, and then second distribution is the same lang nung gagawin mo dito. Okay, so I can just malimutan kong lagyan ng F4 to. So I can just copy this one, the first two, and then paste. Okay, and then ito punta dito. Okay, so since 0, 0 ito, yan. And then sa manual, kahit wag mo nang ilagay yung 0, 0 na yan. Okay, so mangyari lang kasi dito is equals. Again, the final moment is just take the summation from FEM to the final or final distribution. In this case, third distribution. Okay, and then we drag that down. So taking the sum. Okay, so automatic. So, let's compare our answers from the original. So, automatic 0 yung sa pin support, final M, 38.66, negative 38.66, 23.524. So, let's compare it from the original. So, that is 0, 38.425, negative 38.425, 23.781. So, as you can see, it converges faster to a good estimate of an answer. So, huwag kayong mag-alala kung hindi eksakto yung magiging ano nila, or hindi sila magiging exactly equal. Okay lang yon. Basta konting decimal lang, okay na yon. Basta importante is mag-balance tong sa dulo natin, no? 0, 0 yung total nito kasi 38.67 minus 38.67 is 0. Okay, so yun yung modified stiffness. So kapag ginawa mo yun, you can now proceed doon sa section analysis and then solve for the internal shear forces and then draw the shear and moment diagram. As you can see, mas mabilis siyang isolve. Okay? Kasi pagdating dito, mapapansin natin halos balance na sila eh. Okay? No, check mo yung sa second distribution ng original. Hindi pa sila balance. Okay? Pagdating dito sa modified stiffness, mas mabilis siyang malapit mag-balance. Okay? So, malapit na mag-balance dito eh. Kaya pagdating dito sa carry over dito, 0, 0, 0 na siya. Okay? So, ibig sabihin it converges na to a good estimate or a good answer na. Okay? So, that is for our modified stiffness.